Hello, I am Andrew Arma, and this is my presentation on Lab 3 for Physics 2212. In this lab, we investigated the magnetic field of a bar magnet and how the distance from it and angle relative to it can affect its strength. The results were as expected. Strength increases as the magnetometer gets closer to the bar magnet. Magnetic fields are created by two means. The first way is by a current traveling in a loop, and the second way is by a magnetic metal which naturally produces a field. This lab investigates the latter, which works similarly to an electric dipole, where the field goes outwards from the north end and inwards toward the south end. In this experiment, the system of the magnetometer interacts with the surroundings of the Earth's magnetic field and the bar magnet. The primary instrument in this lab was a bar magnet, and the main purpose was to see how the X, Y, and Z components of the magnetic field are affected by distance, both on and off axis. We do this using a magnetometer and a ruler. First, we aligned the phone with the Earth's magnetic field by seeing where the X component of the field was at a minimum. Then we found the location of the magnetometer by seeing where the X and Y components of the field are at maximum, and the phone is aligned with the bar magnetometer. The magnetometer was in the upper left corner of the screen, and this location was used for all subsequent tests. After this, we measured the distance between the phone and the magnet when the net magnetic field on the phone was at a strength of 20, 70, 120, 170, and 220 microteslas. Unsurprisingly, the shorter the distance, the stronger the field was. This matches the formula which states that the magnetic field is related to the distance by an inverse cube. However, we found that our data suggests that R is an exponent of negative 1.2, which is much less than the expected negative 3. This could have been affected by people who started using laptops near where we were doing the experiment halfway through. Before this, we made certain that all electronics were kept far away from the experiment. Here's a snippet of my code that models the field. If the magnetic field of the North Pole had not been accounted for, our data would have varied wildly. The only reason we could get consistent results was because of all our fields besides the bar magnet were kept constant throughout the experiment. If we had changed multiple fields during the experiment, our data would have been incoherent. If we stuck two magnets together and then repeated the experiment, most of the qualitative results would remain identical, but the distances would have to be further away in order to compensate for the increased dipole moment of two magnets instead of one. And that's my presentation. Thank you for watching.